Hi, my name is Scott Albers. This is the second video in the series of videos I'm giving as a result of two papers that have been written, one with my son. The first paper was entitled On the Mathematic Prediction of Economic and Social Crises Towards a Harmonic Interpretation of the Conjurative Wave. That paper was described in the first video at some length. This second video is building on the mathematics of that first video and refers to a second paper. That paper is titled Okun's Law as a pi-to-1 ratio, a harmonic trigonometric theory as to why Okun's Law works. The first thing I'd like to do is to describe what Okun's Law holds, at least in principle. The question is, assume for the moment that we have an economy such as the United States and there is absolutely zero growth. And yet we assume we have some level of unemployment. To reduce the level of unemployment by 1 point, by 1 percentage point, how much growth should we have to anticipate or encourage to make that unemployment go away? If we have an x, y, z axis such that y equals the level of unemployment, and if we have an x-axis equals the level of real GNP growth, what is the angle, what is the slope of this line that says that as we grow more and more and more, the unemployment will actually come down? This represents 1 percentage point of unemployment. So how many points of percentage GNP growth do we have to bring this down? And the answer that Okun gave in about 1960s was it basically takes 3 points of real GNP growth to bring this number down to 0. In other words, if we want to have 1 percentage point of unemployment to be brought down to 0, we have to increase GNP by 3 points. Now, this particular law is one of the few laws of macroeconomics. Every country has been found to have some sort of ratio that goes on, but every country has a much different ratio. In Spain, it's one thing, in Japan, it's quite a different one. In the United States, it has tended to be around 2 to 3 points. The second paper that was written talks about a specific geometric ratio. And this is in line with the idea that in the United States, social and economic cycles are geometrically based. By that I mean they are not simply the cause and effect of a bunch of random things happening, and this is how the cause and effect happened at one particular point. There is a geometric characterization of all of this data over a long period of time, such that very, very key and well-known mathematic ratios continually come forward in the data. Now, in this second paper, the idea is that if we can demonstrate that the ratio of unemployment to real GNP growth is not 1 to 3 or 1 to 2.7, but actually 1 to 3.14. If we can demonstrate that, we have shown something that is really rather key in terms of the very nature of reality. How is it possible that an economy with 300 million people over 200 years can actually generate geometric ratios? How does that occur? How can you actually describe that in the data? And for that, we have gone to Kondryatiev's wave in the first paper, and in that capacity, I want to describe some of the more important findings in the Kondryatiev paper. If we're going to say that there's a 1 to pi relationship between the dropping of unemployment and the increase of real GNP, the question arises, where can you find that in the data? How does that actually manifest itself? And the way in which it does that is described in this paper in some detail. I'd like to run through some of the more important elements of it briefly in this video. In the Kondryatiev wave video and the paper that was described recently, we've made the point that every 14 years, on an average running from 1869 to the present time, on average, every 14 year would see a 1 to 1.6180 increase. That is to say that if you have a GNP of one date, say 1870, by the time it returned to 1888, you should have a ratio of 1 to 1.6180 on average. Now, if you understand that particular idea of a GNP increasing every single year to larger and larger and larger levels, the question arises, what interest rate, compounded annually, would be necessary to encourage that, or to accommodate that kind of growth? This is not a statistical question. This is a straightforward geometric question. And the answer is that for the future value of any particular amount is the present value plus times 1 plus the rate of interest times the time period that is being considered. In this particular situation, if we had a fictional GNP of $1 million and we want a fictional GNP in 14 years of a 1 to fee ratio of $1,618,033, if we want to have that fictional GNP turn it in 14 years to that, then we put the T in for 14 years, and the interest rate that we're going to be looking at is a 3.4969% rate. That means that if we have a 3.4969 annual percentage interest rate, this will turn into that in 14 years. The question is there anything in the literature that would provide some sort of basis to believe that 3.4969 growth rate has any sort of validity? Now, in a paper that was written by Edward Notek called "How Useful is Okun's Law?" Dr. Notek, who is a researcher at the time with the Kansas City Federal Reserve, wrote a paper called "How Useful is Okun's Law?" And as he was looking at the annualized GNP unemployment growth in relation to Okun's Law, he discovered that, in fact, the x-intercept for this particular form of data was 3.4971. We would be looking for an intercept of 3.4969, which means that there is a difference between what he found as an annualized definition versus what we came up with geometry of 0.00002 by way of proximity. The understanding was that there must be something going on between the annualized version of Okun's Law and our understanding of the conjugative wood. There must be a comparison. There are two ways to look at macroeconomic data. There is an annual version and there is an annualized version. These are two different ways of taking the same exact chunk of data, dividing up it in different ways with different ideas, but coming up with very interesting insights as to what that data means. If you're going to look at annual data, and you're going to look at real GNP growth on an annual basis, the way it's done is you take December's calculation, followed by the next December's calculation, followed by the next December's calculation, and at the very end of all of these years, you end up with the annual statement of real GNP growth from year to year to year to year. That's the annual GNP growth approach. The unemployment approach is the same thing. What is the December rate of unemployment, followed by the next December rate of unemployment, followed by the next December rate of unemployment, and that gives you the change between these two figures. To get an annualized version, you take the first quarter of the year, January, February, March, you average that, and then you apply a mathematical formula that tells you what the difference is between this on a quarterly basis and apply it to the entire year. So you're taking basically whatever growth there was between this quarter and that quarter, and you're annualizing it. You're making that statement for the entire year based upon the changes between a quarter. In this situation, you are simply using the idea of a 1 year period. That is the fundamental part of annualizing anything. Over here, you're looking at from year to year to year to year over a long course of time. The idea is that this 3.4971 that Dr. Notek discovered, or had in that particular data, is not being generated through some sort of strange chance. What it is actually the growth rate that's necessary in the United States to accommodate conjugative waves over 56 years, and that particular rate, as it's going to be used to understand this paper, is going to show that the angle that is here, representing a 1 to pi relationship, is the same angle with a 1 to pi relationship here with simply a different x-intercept. The way in which the article describes how this 1 to pi relationship is developed at a 3.4969 x-intercept is the heart and soul of the article. But the heart of the whole idea is that in the United States, social and economic cycles are geometrically based, that they are not something that is simply the result of cause and effect at a random basis, that these things are principles that will be applicable not only to social and economic studies, but perhaps on a much broader basis. Thank you very much.